Hi, thanks. I'm Peter. It's nice to see at least some people have stuck around. It's like a little bit more vacant than earlier, but all right. So I've titled this a View of Elm because it lined up nicely with the names of the other talks. What is Elm? There's a few different parts to Elm. It's obviously a language, and yes, it compiles to a giant blob of JS, and no, you can't control that, so you just have to deal with it. It's also a runtime, which is probably the more novel part, and that's kind of referencing the fact that your Elm programs need to fit a certain kind of type, and that type has limits on what can pass into or out of it. So you're kind of always generating HTML, and you're always kind of talking to the browser in a certain way. And it's an ecosystem, so it's got its own package manager, and it actually has a very strict vetting of packages. So I was just talking to this guy over here, and he's asking about, can I write my native Firebase module thing? And probably not. And so if you want to get your package into the Elm package manager, you basically have to get it approved by the Elm author himself, and he kind of denies any package that has any native, like native being just JavaScript stuff. So it's like he wants pure Elm stuff, he wants people to write Elm first, and if it's native, he's kind of the one writing it. It's not always true, and there's workarounds, and you can always kind of tweak it, but typically, that's the story. A disclaimer, I'm just kind of going to introduce things as they're necessary, so I'm not going to take you through step by step. Here's the building blocks of Elm. So there's strings, there's ints, it has stuff in it. It's a language. It's a normal language. Ooh, that's not great. Okay. What does Elm prioritize? It prioritizes basically getting up and running as quickly as possible. So it gets you from 0 to 100 really quickly. It really is focused on building web interfaces and not a whole lot else. Like even running tests, it kind of like spins up a fake little web thing and runs through that, through a node thing. Batteries included. By that I mean it has a really comprehensive standard library. It's not huge, but it has stuff you would need. So the symptom of that is you're not going to have a left pad issue in Elm because no one's going to need to tweak and add a little thing that the JavaScript maintainers forgot to add. And it has a nice little dev server by default. You're not reaching out of Elm to get everything you need. This is that little dev server. It's called Elm Reactor. So when you leave this talk and you go home and type npm install Elm, the next thing you write is Elm Reactor, and it will just start up a little web server on port 8000, and you can start coding. This is what it looks like. It kind of comes up and shows you all the dependencies in your app, and there's not many, and there usually aren't many because of the nice standard library. And it gives you a file navigation thing, and you can just click the file you want to run, and it will just come up and start running your app. So just jumping straight in, this is the simplest, not quite smallest, but it's an Elm app. So you have this weird sort of ugly HTML declaration. So we're importing HTML. You can alias your imports. So we're saying HTML, we're going to call H from now on. And we have a strong element with some text in it. That's all that's going on. And because it's main, and main is a special word, Elm knows to plug that onto the page when it runs up. And it's a lot of people's first gut reaction is, oh, this is just the most disgusting. Who's going to write that? Why is there an empty array there? What is that? What is that? Why do you need that? The purpose of that is if you have attributes, so if you wanted to have like a class or a disabled button or something like that. To that point, I would say, this is a React, that's React, right? Create element with strong and a null set of attributes and your string. So it's kind of the same thing. Here's a little bit of a bigger example. So once again, it's just a section on the page. This is like a cafe. I'm going to set up a cafe here because there's not enough hipster food available on this side of the room. So we're going to sell some Ethiopian lamb and some comfy salmon. That's just kind of a static page. It's just going to show some list items on the page. But if you notice, we had that list item over and over and over again. We can kind of pull that out and put it into a variable, right? So now that we have this items, which is all the items that might be on the menu. We want to view each of these items, and I'm purposely kind of going ahead on this. We're going to view each item. Each item is just a list item. And then we have a section where we're mapping over, I can't move the mouse very nicely, but we're mapping over all of the items and viewing them. So basically, call that thing on all the items and put them on the screen. The interesting thing about that is in Justin's talk, he says never reach out of that, your function or whatever it is. So where we have items down there at the bottom, that could be anything in JavaScript. You can change that. Someone else might mangle that, set something on it. It's not going to change here. Items was always going to be that list of 3 things. And if you wanted to change items, it would just give you a new list of items. You're not ever going to change the underlying value of what that items thing is. So it's totally fine to do that. It doesn't break referential transparency. Main is always going to be a constant section that shows all those items no matter what. But you do have some functions to make it easy to create those new versions of things. So one of the core things in Elm is a record, which is kind of like a little object hash map dict thing. So if you have like a person whose name is George and he's 26, we want to have a function that tells us how old people are, what they look like after they've had a birthday. So let's say a birthday is, we're updating this person value on the left. So this is the thing we're updating, that's a record. This is the field we want to change, and that's what it should now be. So it's just their old age plus 1. And so George is always going to be George when he's 26, and older George is always going to be George when he's 27. It's like that forever. If you wanted to write this in ES6, you're kind of going to end up with something like this. It's not too different. So you can have a George, have a birthday function. The difference here is kind of that you're like splatting out the person and then overriding his age, rather than it's kind of the same thing. The implications of this, like what does this mean in your app? You can always refer back to the initial state of your app. So if you have a long-running thing, or maybe you just want to restart some kind of thing, you always have the initial state available. You can grab back to it. You can also step back through the different versions of your state, because each one is self-contained. Also, you're never going to be having someone access the data you're working on out of band. So if you're working on some kind of a dict, or you're like reading values out of a hash map or something, somewhere else in the program, like if you did an async call, you send off a request, do a web request, it comes back, sets some state somewhere or something, that's never going to mess with what you're doing. You don't have to worry about it. There's no chance of that happening. And typically, what this is like to work on is your function will take some kind of an argument. You might modify it somehow. You are forced to return something, so you might as well return that value, and then someone else can do something with it. So you kind of like propagate values through your program. So now getting back to what actually is this function. So this is the initial view item function we had. This is the name, so that's just what we're going to call it. View item, you can refer to it as view item through the rest of your module or package or whatever. This is arguments. We just have one argument, but you could have many. They can be anything. And this is the body. You'll notice there's no return. It's an implicit return, and every function has to return something. And it's kind of through this that later on we'll get to, you're not going to have any side effects or like things happening that you don't expect to happen. So in Justin's talk where he's saying, this could open up a thing on the disk and start writing to it. There is no chance of that happening without your knowledge, because the return type of your function has to reflect what's going on inside that function. So if you want to perform like a web request, your return type will be of a command. I'm commanding you to do something. So it'll be immediately obvious what's going on. So let's break this. We found a lot of people buying the avocado, and we want to price it up a bit higher. This is kind of going back to Rob's talk, where we're going to use this like kind of change debug workflow. So compilers come back and said, hey, your second entry doesn't look quite right, because the third one is quite different. One's a string, one's this weird thing, and it gives you a cool little link, and it describes to you every entry in the list needs to be the same type of value. This way you can never run into unexpected values. That's nice. So it's kind of explaining to you what's gone wrong, how to fix it, where exactly it's gone wrong. And the creator of Elm, Evan, has put a lot of work into getting these error messages just quite right and feeling quite human. So let's just put a price on everything. And that should fix the problem. Except it hasn't quite fixed the problem, because when we're viewing items, we're expecting that thing that we're putting in the list item to be string, and now it's this weird name, price, record. So all we need to do is change our view item function to print out item.name, and the whole thing's happy. So what's happening here is it's doing type inference, but we haven't declared any types anywhere. So similar to Rob's, it's tracking the values. It's tracking the values as they flow through your system, and seeing how they're used in different functions, and then assigning a type to them and making sure that your program is internally logically consistent. So it just kind of like does the right thing. It's basically saying, hey, you screwed up somewhere because I know what's going on in here, and you should too, but clearly you didn't because you did the wrong thing. So it does the right thing, and it's global. It's across modules. It's like in Go, there's kind of like a type inference thing where you can like say, oh, A equals B, and whatever it be, it kind of just works it out. But this is on a global scale. The whole thing is type checked, and it all kind of works together. But this is a really boring program. It's just printing out just a section and some list items. So we want to be able to poke around. And yes, we're going to do a to-do app where we change the stuff in there. So are you going to reach for Elm Redux? You are not going to reach for Elm Redux because everything's included in the standard library. So instead of that, in our HTML package, there's a cool little function called beginner program. And what that's trying to tell us is that it's expecting a model, a view, and some update thing that we haven't heard of before. So the view we already kind of have, that's our view items. The model we already kind of have, that's just items, but we don't have an update. So we just need to change our view slightly because earlier, if you remember, it was reaching out and grabbing the global items, but now we're passing it in as an argument. So that's the one change we need to make to view. And updates, what are updates? So in Elm, and also in Redux, and Redux was inspired by Elm, you kind of have the concept of a message, and a message is an intent to perform some kind of a change on your model. So I'm going to receive a message like, go get that URL, or update a counter or something, and then your update will respond to that message. So in this case, we're going to just maybe remove the first item from our list. So we have a remove one message, and update is a function that takes that message and the current model and drops just one thing from the model. So when it says remove one, we just drop whatever the first item is. And that's an implicit return. So that whatever that list.drop one model thing becomes our new model through the power of that beginner program wiring. And this is all we have to do to plug it into our view. So we just add a button that when you click it, we remove one. That's all there is. And this is the wiring that I mentioned a second ago. So we're just plugging items in as the model, update is update, view is view, and that will compile. I don't have a GIF of it all working, but trust me, it works. If we want to extend messages because we don't want to just remove all the items from our list because then it'll be an empty list in a really, really boring website. Let's say we want to create an item, but we need to have something to create, so we're going to track some user input, and that update input is like the user as they're typing into the page. So the interesting thing here is that this is like an enum, like we had in Rob's talk, where it's like it can be this or this or this or this, but each tag in the enum can be parameterized. So like our update input actually carries extra information with it. It carries a string along with it, and that could be anything. It could carry 10, 20, 50 million things if you want. So the minute I write that and save it, my program starts complaining at me and it says, hey, in that case statement you wrote like 5 minutes ago, you didn't actually account for these new messages that now exist. So it's actually saying add branches to cover each of these patterns. So you need to account for the fact that update input exists and create item exists. So all right, let's do that. But in our old model, we only had a list of items. We didn't have a spot for input. So we're kind of changing our model here. So we're saying, okay, the model will have items inside it. It's going to be that record. We had that record of update syntax earlier. So inside the record of model, let's drop that item thing. That's the one we used to have. When we update our input, let's just say the input is whatever that string they sent through was. And when we create an item, let's take the input, slap it on the front of items, and then reset the input back to be empty. So you're kind of like taking care of the entire thing all in one case there. Once we do that, oh geez, it's still complaining, and that's because we changed the state that update was expecting without changing the state that we were passing into our beginner program. So it's still saying items up here, which is just the list of strings. So we can just redefine that. We still have our items, but we'll wrap it up in this little init that has an empty input. And then in the view, it's getting kind of big and ugly now, but this is the part that matters. We have an input, and on input, we update input, and the value is being tracked by that current input value in our model. And then we have a button that is nicely disabled whenever the string is empty, so it kind of like reacts to what the state of the thing is. And when you click it, we create the item. And here's proof that it works. It's a to-do list. You can add items to the list, and then you can remove items from the list. So it does work. Now we're going to get into probably the more interesting part of this is managed effects. So if you need to do something outside of this happy little world in Elm where you can pass a value up and down and it goes around and stuff, you need to talk to an actual server, or you need to generate a number. You need to get the time or like real stuff. They've got this nice system called managed effects, and what that's kind of saying is pass something off to the runtime and let it schedule it, do its work, and then come back to you when it knows what's happened. So an example would be like, generate me like 50 names. I need to fill in this form. You say generate them all, and when you're done, come back with a I generated my names message, and then I'll fill in my state in accordance to that. So the HTML app supports that as well, so you still don't need to reach for Redux or anything. It looks bigger, but it's not that much bigger. What's changed here is we have a subscriptions thing that's useful for things like WebSockets, so you can just like dump values into your long-running program. The view stays the same. The init now takes like an initial command it can run, and the update, instead of taking a message and a model and returning a model, it returns a model and potentially like a command message thing, which becomes more clear with this example. So this is like an actual HTTP call to get all the top stories from Hacker News. So imagine that you knew what top items decoder was. That's a thing that decodes JSON values into a type in your program. But you're basically saying, go and get me these top stories, and when you get them, decode them into this top items thing. That's not a thing that actually runs right then and there. That's just describing a request that can be run later. And even later on when we say, okay, let's HTTP send, and when you finish sending, come back with got stories, that still doesn't get sent there, even though it's a command. It's just the intent to perform the command. The only way that a command is actually going to get fired off and handled by the runtime is when it's returned through that update function, when it gets wired in. So what this is going to do is it's going to go out and get all the stories and come back with either an error or some set of top items, which is just a list of IDs from Hacker News. And here's some terrible, awful, contrived example of if we got all those stories and then took 10 of them and then got all the authors, and then from each author, got the story it went to, could we get all the users? And basically, the point of this is to illustrate that there's a lot of stuff happening here. And imagine this stuff has type definitions because it does. In that little callback inside a chain, inside a function call, we have item.by. If we change that to item.from, the whole thing comes crashing and burning down because it can tell that, hey, you were trying to talk about a story, but specifically, the fields in your record don't match up. One has by ID, score, and title, and you used from. So I haven't annotated a single thing so far. I haven't said this is a user, this is a whatever. It's just figured it all out, and it knows, stop trying to access that attribute, dude. So just to bring it all back, Elm is a labor of love by Evan Klazipski. I don't know how you pronounce his last name, but he's basically got an unwavering focus on creating this like nirvana experience of you don't ever have to touch JavaScript and you can just live in this happy little world. And for the most part, that's true. And when it's not true, it hurts because it's hard to work around his designs. Like if you need to use a native module, it's not documented. You need to kind of like dig around and do it on your own. So it's a pro and it's a con. But interestingly, in some ways, I would say that Elm almost represents the antithesis of modern JavaScript, right? And I would say that because there's one build tool. Like how many build tools do we have for JavaScript? There's a new one every week, and there's going to be a new one next week, and each of them is configurable. So with Elm, you type Elm make, and you get your giant blob of JavaScript, and it runs actually really fast because he's written his own virtual DOM, and it's just one man's thing. So it's a blessing and a curse. Another thing is you have really shallow dependencies. At work, I have typed create React app, and then created the React app, and then looked at my node modules folder. It is 650 megabytes. It's almost a gigabyte of dependencies in this create React app thing. With my Elm app, it's like 4 packages that are like 3 files each. So it's not huge. And also, thorough package vetting, whereas in JavaScript, everyone's got to get that package to the top of Hacker News, so they're just like pumping them out, There's also a focus on ergonomics and correctness at the expense of release speed. So similarly, in the JavaScript world, everyone wants, well, this is a generalization, but you want to get stuff out, release early, release often, move fast, break things, the whole thing. Evan constantly, there's a secret little Google groups called Elm Dev, and you can go and see all the stuff like, don't post this around, guys, but it's secret. He constantly says, it's going to take a while, just be patient, please be patient with me, I know what I'm doing. And it's like every month he's saying like, it's coming, I promise. So he's got a cohesive view of how he wants this whole thing to fit together, but you have to wait for it. And kind of lastly, that it gets better as your code base gets bigger. And I think that's kind of the inverse in JavaScript, where it's like, the bigger it gets, the more chances there are for things to go wrong, or the more ways that there are your program could fail. Whereas with this, as it grows larger, a change here being tracked everywhere, you can very easily refactor all your code and be sure that nothing weird is going on in your program. But if you still want to write JavaScript, like there's some stuff you can steal. There's this cool little package that has like only like 280 stars on GitHub. I don't know why it's not popular, but it's called union type, and it kind of gives you that nice pattern matching stuff from Elm. So you can like define it just exports one function, this type thing at the very top. So you can say I have like a type, and it's like I'm either going to update my input, create an item, or remove one, and that string is like the arguments that it has. And then you can later on case on it. So if you have some kind of a message, you can call case and check if it was update input, do that thing, remove one, or create item, do that thing. So that's kind of like a Redux reducer right there. Another thing is, I know this is React centric, but with Redux, you really can write an entire app without classes or minimal classes, and especially without touching state. So you can definitely do it without touching state. And one of the few uses for classes is like if you need to watch as things get mounted in the DOM or something, if you need to, set attributes higher up outside of your DOM, or outside of your React tree. You really can do a lot with pure components. Another thing you can do is structure your modules. So if you just have a consistent approach to how you export your JavaScript modules, like let's say I'm going to export my connected component, the actual component, some reducer, and the initial state, like you can really easily abstract that into some wiring and kind of have it take care of the glue for you. And the reason you might export the raw component is just so you can test it and pass values into it and make sure that it snapshots well. Another thing you can do is just start with the pure version of something, right? So every time you say, oh, let something be that, you're opting into mutability and you're opting into having your values change out from under you. Whereas if you just go for a const, you can be more sure that the things in your program are what you think they are. And the same goes for class. Like the second you pull out a class, you're opting into having a bunch of mutability and state and having to concern yourself with how those values are getting passed around in your program. This kind of might, well, no one's going to say don't start simple, but start simple. There's this kind of trend in the Redux and React community to like break things into like hyper small files of like this file only does one thing and it only concerns itself with one thing. But in Elm, each file is like a module is a file. So you kind of group related things into one file. And it kind of pays off in JavaScript as well, where just wait until you need to break it apart before you break it apart. Like wait until it gets too complicated to actually start refactoring things, and wait for patterns to emerge as well. Like if you see that I've broken apart this like list item into its own thing, and then I'm using that in 4 different modules, then maybe it should become a component. But don't like automatically just slap everything into a component. And finally, maybe just try Elm. Like even if you're not going to use it, just give it a try, and having that perspective might influence how you develop your JavaScript programs. And thank you.
Steve. Hi. You've got a question, you're fine. Does anyone else have a question for Peter?
Yep.
You mentioned to have any side effects, you need to return a command.
Yep.
How do you achieve progressive side effects over time? Like, if you want a function to do multiple side effects?
Does this work? Yep. So in that, let me see if I can explain this. So basically that command that it returns, you can batch commands together. So you can take 15 commands that return the same message and batch them, and then it is one command. You can also, and there's actually a built-in operator. I should have shown it, but there's a built-in operator that takes a ton of commands and like merges them into one command. You can also do this weird task jumpy thing that I did in this slide back here. It's worth showing. So this is like a ton of stuff happening, right? So this is like an initial HTTP call and then 20 other calls. So it's getting 10 items and then making a user and then a story call for each one of those things. And that's all getting batched up into one kind of command that's happening. So you can like chain these things together. And like that's like this crazy promise that's type checked, and you can all just kind of pass it off at the end. And if this is kind of a terrible way to do this because of that task.sequence thing at the bottom. So it's going to run item author over and over and over one at a time. But you can, if you use command batch, you can basically get all the things and then have a ton of messages, like 10 messages come back at once. So you can kind of decide how do I actually depend on the previous value before I get the next, or can they all come back at the same time or what? But it's doable. Also, when that command comes back, it's going to funnel through your update function, and you can just fire another command from there. So it's a way to do it without doing all this weird chaining stuff. Yeah.
GraphQL?
Don't know. Yeah, I haven't touched it. No.
Question. How is it with GraphQL?
I haven't touched it. I don't know. Sorry. I'm not that bleeding edge.
One more to the back, and that's the last one.
This might also be a super quick one, but it seems to me that it occupies a similar space as ClojureScript's Elm, so I'm wondering if you have any thoughts about Elm versus that.
I have no first-time experience of Elm, but I've read a bit about it, and it seems, yes, they do roughly the same thing, except the type checking in Elm the type checking in Clojure, like, it's kind of opt-in and not as pervasive, I would say. So, like, I've heard good things about Elm, yeah. And it's a similar sort of structure. Cool.
We thank Peter, please.